This question says, first rewrite the quadratic function in vertex form by completing the square, then complete parts A through G. So first we want to rewrite using completing the square. So my function is f of x equals x squared plus 6x. So with completing the square, the first two things I pay attention to is whether our function has a coefficient and whether there's a constant here. I don't have to worry about either of these. I do have a coefficient of 1, but we only need to do something if that coefficient is other than 1. And then we set aside the constant. So we don't have to worry about either of those two things in this example. So then we'll get right to the completing the square process. So with the completing the square process, you need to start with the coefficient of the x here. I'm going to do this work on the side. I like to call this the magic number. So you start with that coefficient on the x, then you're going to cut it in half and square it. So that gives me 3 squared, which is 9. So our magic number for this example is 9. And I want to add that 9 to this group right here. But if I add 9, it changes the function. So I need to balance out by doing the opposite, which is subtracting 9. I'm going to focus on this group of terms, and those group of terms can factor, and they factor into something special called a perfect square. So if I factor, I would get x and x, 3 and 3, both pluses. And so the reason why it's called a perfect square is because both of those factors came out to be the same, and you can put them together into that perfect square binomial. So now we can see that it is in vertex form, and that's what you would write for this first part here, x plus 3 squared minus 9. We can also figure out what the vertex is from this vertex form is f of x equals a times x minus h squared plus k. So if we pay attention here, we've got, minus h. So in the h spot, we have this 3, but notice it doesn't exactly match up. This one has a plus, the other one has a minus. We really have to do the opposite of that 3 there. So our vertex is going to be -3 and -9. So the k part lines up with this -9. So you may wonder why that is. And so here's my explanation. We want this x plus 3 squared minus 9 to match the format, and plus 3 can be written as minus a -3. And now that it matches up, you can see after the minus is a -3. That's a lot to kind of keep in your head, but you can always just keep in mind that it's the opposite of what you see there. So if you see a plus 3, you're going to use a minus 3 in your vertex. If it's a minus 3, you're going to use a plus 3 in your vertex. So our vertex is -3, -9. The next part says, does the graph open up or down? Does the graph open up or down? And we're going to use that value of a to say whether it opens up or down. So our value of a would be 1. A is 1, which is positive or greater than 0. So that means that this parabola is going to open up. So it opens up. What is the axis of symmetry? So for the axis of symmetry, it's going to be a vertical line. And the vertical line always passes through the vertex, so that's going to be x equals -3 for the axis of symmetry. So because it passes through the vertex, we're going to use the x coordinate of our vertex for the axis of symmetry. The next part says to find any x-intercepts. So you find an x-intercept by letting y equal 0. We're going to let f of x equal 0. And you can you can do either the original function equal to 0, or you can do your vertex form equal to 0. In the last problem, it was in vertex form, so this one I'm going to do in the general form. So to solve this, I'm going to factor. I can factor the greatest common factor of x. That would give me x plus 6, and then I can set each of these factors equal to 0 to get x equals 0 and x equals negative 6. So those are my x-intercepts. The next part says to find the y-intercept. You find a y-intercept by letting x equal 0 and finding f of 0. That's 0 squared plus 6 times 0, which is 0 plus 0, and that's 0. So we have a y-intercept of 0. So now we're going to sketch the graph. That's the next part, sketch the graph. And we want to plot our vertex, -3 and -9 would be about right here. We have our x-intercepts at 0 and, excuse me, let me fix that, -6. And our y-intercept is at 0. So we have a parabola. You remember this vertex is a special point. That's your turning point. We said this parabola is going to open up. So there's our graph. The final parts are finding the domain and range. The domain of every polynomial function, quadratic function, is -infinity to infinity. And for the range is going to start at that vertex and go all the way up to infinity. Those are the y values that are covered by this graph. So our vertex is at -9, so our range starts at -9, -9 to infinity. Thank you for checking out my videos. Have a great day.